Hello, everyone, and welcome to the Weekly Space Hangout. I am not Fraser Kane. I'm Dr. Pamela Gay, and I am your guest host tonight. Fraser is completely fine. He's completely fine. He just had things come up, which sometimes happens to all of us. I appreciate all of your patience while we got things started tonight. I think tonight's show is going to be more than worth it. Tonight we have our normal fabulous round of scientists, and we also have an amazing guest. Dr. Jill Tarter is with us. Her current title, and here I have to read it off the screen, is Emeritus Chair for SETI Research at the SETI Institute in Mountain View, California, and she serves as a member of the Board of Trustees for that institution. Now, many of you may know her from the movie Contact, where she was the inspiration for Jodie Foster and had a friendship with Carl Sagan that led to that. But what you should know her for is the amazing science she has done over the years as a pioneer in the field of technosignatures, looking for what can we expect to see from civilizations on the other side of, well, our local star region. So she will be discussing that with us this evening, as well as all the other amazing things that are going on with the SETI Institute. Now, alongside her, we have a variety of different space journalists with us tonight. I'm going to start with Pam Hoffman, who is to my left. How are you doing, Pam? You want to introduce yourself?
I'm Pam Hoffman, Everyday Spacer. I am doing awesome, and I'm going to tell you that there's nothing scary about the night sky coming in the next coming weeks.
Okay. I didn't know I needed to be scared of the sky, and now I'm a bit worried. But all right, moving on. Michael Roderick, could you please introduce yourself? And I'm sorry if I just destroyed your name.
You actually got it right.
Okay.
I'm Michael Roderick. I'm a Penn State graduate student. I'm working on interacting galaxies, and so I'm going to be telling you about some evidence of past interactions that we seem to just have found in the Milky Way galaxy.
And Dave Dickinson.
Hey, science writer, longtime amateur astronomer, frequent contributor, Universe Today, Sky and Telescope. Not in a murder scene. It's just Halloween, so.
It's 2020. A murder scene might be an improvement. I'm not sure any longer. So without further ado, I'm going to ask our three journalists if they could please mute their videos, and Jill and I are going to talk about the things that she is currently up to. Apologies that I am not Fraser, so there's going to be occasional kludges going on as we do this. So Jill, this is an amazing time in technosignatures. There's new work being done to try and define these. And before we launch into all that's new, can you define technosignatures for our audience, please?
Well, technosignatures is a word that I made up to be analogous to biosignatures, because I wanted to emphasize that both of these aspects of looking for life fit under the umbrella of a discipline called astrobiology. So in technosignatures, what we're looking for is somebody else's technology that's modifying their environment in ways that we could sense remotely across the solar system or to the distance of nearby stars. So somebody's using technology to astroengineer something, create or transmit a signal, modify their planet, do something that our telescopes possibly could detect and realize were engineered rather than astrophysical.
And this is something that the SETI Institute has been part of doing in the radio spectrum for decades. What specifically are the things that you can see using your radio telescopes? Because I know it's not just leaked television and radio signals.
Well, you can detect, we've also been working in the optical. And so in the radio part of the spectrum, we do look for frequency compression. We look for signals that show up only on one channel of the radio dial, because nature can't do that. Nature's emissions are broader than that. So frequency compression is one of the keys in the radio. In the optical, it's time compression, looking for bright flashes that last a nanosecond or less, like somebody's laser flashing at us. And these are the kinds of categorizations that we've been using historically. But now, actually, it's really exciting because with the advent of artificial intelligence and neural networks, instead of telling a telescope or taking the data from a telescope and asking a computer, does this particular pattern exist in the data? We can now begin to take the data, show it to the computer, and ask, is there anything intelligent, anything that isn't noise in the data, and therefore broaden the classes of signals that we can be sensitive to.
And that is something I have to admit just ruined my next question. I was just going to ask you about infrared radiation. So the universe.
Well, that's actually we're pushing the search, the optical, down into the infrared now that there are good photodiode, avalanche photodiode detectors and arrays. So we are actually trying to push into the infrared because, of course, the infrared is visible across the galaxy farther than the optical. And we've never seen the center of the galaxy in the optical. But the radio and the infrared are not as absorbed and scattered by the dust.
And I don't know about you, but science fiction has had a very important motivating factor in my life. And a lot of the cool stuff from the science fiction I love most appears in the infrared. What kinds of things are you specifically looking for in the infrared? Or not just you, but the field of technosignatures in general?
Well, we're looking for emissions that shouldn't be there, or stellar properties that are altered in some way. We're looking for, ultimately, we'd like to be looking for multiple planets in a planetary system when we get the ability to image and distinguish them one from another. We'd be very interested if instead of being at a temperature that was appropriate for the distance from their star, they turned out to be, say, all the same temperature because somebody had gone and astro-engineered one of those planets. Again, it's the same kind of thing, looking for time compression, frequency compression, and in the optical and the infrared.
And as you're doing this, AI is, like I said, not something that was on my radar to bring up. When you talk about compressed signals, things like fast radio bursts come instantly to mind. How does an AI say this is intelligence when biologists argue about that here on Earth?
Well, we can't define intelligence, right? Any more than biologists can define life. But we can say that the statistics of the signal are non-noise-like, right?
Yeah.
So there does appear to be some information content there. And yeah, I mean, when fast radio bursts were first discovered, some of us put our hands up and said, we could do that with a transmitter. We could make that happen. So turns out, we're now coming up with much simpler astrophysical explanations. But if we saw a signal that was dispersed in the other direction, that is, the low frequency signals arrived first rather than the high frequency signals, we might say, now that could be technology.
And in order to do all of this, you're working to innovate new ways of using telescopes, as well as building your own arrays with the SETI Institute. Can you update us on the technology you have on hand? ATA, for instance, laser SETI, which I think is what you were just talking about with the compressed bursts.
Yes, well, you can see the Allen Telescope Array behind me here.
Yeah.
It's in Northern California, 42 6-meter telescopes. So the first time we've built the equivalent of a large telescope by using a large number of small dishes. The small dishes give you a large field of view on the sky. This is a terrific survey telescope. And by spreading the dishes out on the ground with long baselines, we get very good spatial resolution. So that's one of the really nice things about an LNSD array. And if you look at the new telescopes that are being talked about for the future, first of all, there's Meerkat, which is a prototype for the square kilometer array. Again, it's the same thing, large number of small dishes. It's also offset Gregorian feed low optics, which is what we've done with the Allen Telescope Array.
Can you explain what that is?
Well, so the optics are Gregorian, and the secondary is offset from the center of the dish down to a lower position. So you could have a Gregorian system with a feed high, as in the Green Bank telescope, the large telescope at Green Bank, or you can have the feed in the low position. And in the future, the Gregorian feed low is being the design of choice. And so if you look at artist concepts for the next generation VLA in the Western US, should we ever be able to build that, again, it's the same kind of optics. So I feel that that's something that we've contributed to the field, even if we haven't yet found a signal.
You know, sometimes it's the developing of the technology. I have to admit that I was totally a LIGO curmudgeon, because for so many decades they spent so many billions of dollars and they kept saying, we just need to upgrade and be more sensitive. Well, you guys are, I'm not a SETI curmudgeon because you're finding your own way to do this. You're upping your sensitivity and upping your ability year after year, proving the technologies. So there's a tradition of building slow and steady and improving the entire community as you go. Now, meerkats in South Africa, VLA is in
collecting for their own purposes and reprocessing it, in many cases in real time, looking for engineered as opposed to astrophysical signals. So there's a project called COSMIC, which will be taking all of the data streams from all of the antennas at the VLA, which is one of the heaviest used instruments on the planet. And we will be able to reanalyze that data for SETI or fast radio bursts or other kinds of scientific investigations beyond what the primary observer is doing. And then you mentioned laser SETI before, and that's an exciting project for me, because if we get the ability to build out the observatories that we have so far deployed in Northern California, and should we ever get out of quarantine in Hawaii, and then at about 12 other sites around the world, we will have the ability to look at all the sky all the time at optical wavelengths. This does not yet go down into the infrared, but who knows what optical counterparts, a very transient, very short time duration, we might find in a.
Jill, are you there? We just had a pause. I don't know what happened. We're still going out. Are you there now? I see your eyes moving. Okay. I heard you say we don't know, and then you just froze.
What I was talking about is with building this instrumentation that is looking in the time domain, in the optical, and putting devices around the globe in a dozen or so locations. We'll have the ability to look at all the sky all the time for the first time ever. And who knows what optical counterparts of other astronomical phenomena we might find, in addition to the kinds of SETI signals that we'll be looking for.
And this timeliness is what I love so much about the COSMIC project, where you're running simultaneous. And with the geospatial aspect of being spread around the globe, you're also enabling other people to help you with the GNU Radio project. Can you talk about that at all?
Yeah, well, we've made an alliance with GNU Radio. I don't know if your listeners or viewers know what that is, but they're small radio devices, antennas that can be hooked up to a computer, and then there's lots of software to do kinds of applications like Fourier transforms and that sort of thing. So we're actually doing workshops with students and GNU Radio and looking at how we can use this to expand the kind of searching that we can do, and certainly the kind of outreach and education that we can do to bring in students to learn the fundamentals of radio astronomy, radio engineering. And it's a really neat, laptop and a GNU radio device, and you can start looking at the sky and tracking satellites and doing all kinds of things.
It's really amazing to watch. And I suffer from being a senior scientist, which means far too many hours of my week are tied up in budgets and telecons and meetings and timesheets. And you have ionized to the stage of emeritus. Are you looking for any pet projects where finally you can escape at least the budgets part of being a senior person?
Well, yeah, when I was a graduate student, I started collecting papers on SETI observations. And literally a couple of years ago, I don't know if you know it, but they do make binders that are that thick, right? And so these were paper copies because it was a long time ago that I started this. So we've now turned that into an interactive database called Technosearch.seti.org, where I've tried to give information about all of the SETI observations that have been published, give the references and actually a PDF version of the paper, even though sometimes I shouldn't be doing that, so that people will know what's been done. And if people find something that's of interest, they can at least go back and see, has anybody before me looked at this region or these stars at these frequencies? So I think for me, that's a fun project. And
that just sounds cool.
It will get better as my Drupal 8 gets better.
Oh, Drupal is hard. Drupal is hard. It sounds awesome, and I'm so glad that you are there as a researcher as well as a leader in the field. Now, time is always far too short in these things. What things are coming up that you want to make sure our audience and everyone else out there is aware of that hasn't come up so far?
Well, I think that the decadal is coming up, right?
Yes.
And SETI has had a roller coaster relationship with federal government and federal funding. Yeah, but we certainly would appreciate the scientific community looking at the 14 white papers that we put in and saying, okay, this is something that's really got scientific merit, is worth doing. It might not prioritize as high as some other telescope or spacecraft, but it's certainly worthwhile. And we'd like that good housekeeping seal of approval, because then as we go out to ask for philanthropic funding and foundation funding, we can point to that and say, see, we're legit.
And this makes a very important point that I think gets missed a lot, is the decadal surveys done in both planetary science and astronomy are a gathering of our entire community to say what our priorities for the next 10 years are. And while it's always our hope that NASA, NSF, and any other federal agencies of relevance will take that and use it to designate federal funds, not everything we do is federally funded, and we have to rely on foundations, on donations, and it's through a mixed portfolio. Just like we should have our retirement packages be mixed, we need to have our academic portfolios mixed. So you make an excellent point that everyone needs to be aware of. Sorry, I just went off on my. Please
No.
remember, we're funded many different ways.
Yes,
Did
yes.
I mention I've been doing budgets this week? Um, Now, the SETI Institute is a lot more than just people analyzing radio signals. You also have an amazing summer RAU program for undergraduates. You put on a variety of amazing online materials. What are your favorite things you want to know, you want people to know that they can go either apply to participate in or that they should be watching?
Well, first, although the name is SETI, we have 100, and I think the last number is 108 Ph.D. scientists working there, principal investigators on their own grants on every aspect of the question of life beyond Earth and origins of Earth.
Yeah.
So we cover from microbes to mathematicians. It's a very broad range of scientific exploration, and it's
Oh no, we have another glitch. Come on, come back, internet. You can do it. I apologize. Um, we show 0 dropped frames. I'm hoping I'm going out. We've lost Jill. Come back. You can do it, Signal. Um,
I'm still hearing you, Pamela. I don't know if you're going out live, but
yeah, no, we're going out live. They can hear us. We've just lost Jill. We totally lost Jill. All right. So, everyone else, come back. We're going to, hopefully, Jill will come back. But until then, we are going to move along with as much grace as we possibly can. Thank you all so much for your patience during our confusion. I'm sorry I didn't have a chance to get to audience questions. We'll do what we can to help and forward along questions. I know Beth Johnson out there may be able to help get some information for you behind the scenes. All right. While we wait to see what happens, let's move along to today's top news. And here, um, Dave, I think you've got it with
yeah.
OSIRIS-REx.
Yeah, just a few hours ago, they had the big press conference for the touch and go sampling acquisition at Asteroid Bennu for OSIRIS-REx that occurred yesterday. And we just saw, I'll try to share this video. We'll see if it, oh, I'm disabled, but there is a video out there.
Hold on. I wasn't prepared for you guys.
Oh, okay.
Screen share. I can fix that. I can fix it.
I
This
have a
is
quick
not going to go
animation.
well. All right. So there's going to be some frantic rescramblings of. Can you send me a link?
I think I could. Oh, to the video?
Yeah.
Hang on.
Okay. So we're going to make this work, people. Pardon me while I make some adjustments.
Because I'm writing an article about it for Sky and Telescope tomorrow, so I have the
Okay.
link.
Jill's coming back in. You get me the link. We'll finish
Okay.
up talking with Jill, and life will be good.
Well, technology has not been our friend this evening.
It's all right. These things happen to all of us. So you were telling us about all the wonderful programs that SETI is part of with your more than 100 researchers that you have. Please finish your thought, please.
Oh, well, I mean, it's just that sometimes very often we debate, should we change the name of the Institute so that the world out there knows that we're doing a great deal more scientific exploration than just searching for technosignatures. But in fact, SETI has brand, SETI has a recognition. So we've kept it. But indeed, the dual disciplines of biosignatures and technosignatures are all under the umbrella of the SETI Institute.
And I know I got to know a lot of your staff through the Sophia Airborne Observatory work.
Exactly.
And it's really an amazing research facility. And us little research centers have to stick together. I'm at the Planetary Science Institute for my
Right.
day job. And do you have any parting words on this day filled with technological chaos that is here and not affecting your instruments? So we're absorbing the damage for them.
Yeah, I think that I've had the fortune to have a long career. And over that career, I think exoplanets and extremophiles have been real game changers. So we now know that there's a lot more potential habitable real estate out there than we might have thought at one time, or certainly when we started. And so I think the game now is to try and figure out if any of it is actually inhabited. And that's going to be a fantastic exploratory science for the rest of the century.
And my goodness, so much energy is going into finding all those worlds, little and big, and I can't wait to see what amazing things we learn about all of them. Thank you so much, Jill. What one place should people go to follow everything you're doing if they can only go to one?
SETI.org.
Perfect. Thank you. It's
Okay.
always a pleasure.
Thank you for having me. And now I'm going to leave, and it's not a technical glitch.
Exactly.
Okay, bye-bye.
Bye-bye. All right, so I am pulling up Dave's video. Just one moment.
NASA put out a short video. It's sped up about twice the speed of the actual, so it looks a little more violent than it actually was. It's interesting. It looks like they actually blew a small, very tiny crater with the TAG-SAM instrument. We were talking about that on Twitter, me and somebody else. It'd be interesting to see a wide field view. And I think in the coming days, they said there's more wide field images we haven't seen yet from the actual, when they did the contact over the Nightingale site, when they did the Bennu sampling. So the contact was a little longer than we thought, because the timer I had read was set for 5 seconds, because they don't want to contaminate the sampling that they're bringing back. The whole idea is to bring back a very pristine sample. So they don't want anything from hydrazine from the spacecraft or any outgassing or anything. They even went down with OSIRIS-REx in a Y configuration with the solar panels up, just in case they didn't want any debris to hit it or anything like that. So, but it's kind of intriguing to watch the actual video of it. It's coming back. Well, the big question now is, did they catch anything? They're not certain yet. The first thing they have to do is they're literally going to take the TAG-SAM arm, it shoots nitrogen gas down there. That's why you see the violent eruption when it hits the surface. It has these little metal spring. They're hoping that some of the material got caught in those that's deliberately placed on the end of the pads of the contacts. They're going to pull it up and literally look at it with one of the cameras on the spacecraft. And that's happening Friday, I believe. So we may see the first images. Then they actually want to spin weigh the spacecraft. And it's kind of clever because they've done it with it empty. Now they're going to do it once they back off from Bennu. They're going to do a very slow spin measurement to try to see if there's any extra material in there. The amount of material.
And that uses the angular momentum.
Yeah, that's very clever how they do that. They were talking about it in the briefing, that they can actually spin weigh the spacecraft on site to see. They're not collecting much, and I'm amazed they can measure that small. They want to collect like 60 grams, which is like 2 ounces. When I wrote my Sky and Tel article, I was trying to find what's a household item. A C battery is about 2 ounces. That's how much material we're looking to bring back, is about the size of a C battery in mass. So, and they can weigh within 20 grams, they said, plus or minus. So if they get 80 grams, they're like pretty certain they got their minimum weight. They have 2 more sample attempts if they didn't get anything this time. I'd be surprised if they didn't. If you watch the video, it really looked like they stirred up. I was thinking, we were talking, it's like they should have a net or something, because you see all these rocks go flying once they hit. But there's 2 more sample attempts. They can't go back to the Nightingale site they mentioned because of any chance that they might have contaminated it on this sample attempt. So the next site would be Osprey, and that would be January 4th, 2021. They would try to do a sampling attempt. It's actually kind of hard to get in an orbit of Bennu, because we were asking, it's like, well, why are we waiting 3 months to go back if they didn't get anything? They said, well, to get in, the asteroid's only half a kilometer across, and the gravity is so feeble that for them to go in, they kind of go out hyperbolic when they're leaving the asteroid. So then they're kind of doing a station keeping, following Bennu on its orbit around the sun. To go back into orbit really takes some time to get back down to that point where they can stay in its 4-hour rotation and approach. The area that they were trying to hit on Osprey was about the size of 2 parking spots, is what they said, like car parking spots. It's not big. And they were really accurate, though. They said they had a range of about 25 meters and they hit it within 1 meter. So that's pretty good. So hopefully we'll see this after this weekend. We should know the big question is, did they catch anything? And we'll see those rocks, and those will be coming back in 2023. Oh, and there are rocks coming back earlier, and that Hayabusa 2 is coming back from Ryukyu in December. That's already en route. That's already heading back. So that's the Japanese mission. And Japan and Canada contributed some to this OSIRIS-REx. They're going to get tiny samples of this return as well that they were mentioning. I thought that was kind of interesting.
And as a reminder, a group of CosmoQuest citizen scientists
Yes.
marked millions and millions and millions of objects on the surface of Bennu to help everyone involved find where are the least horrifically rocky, bouldery places to possibly land. So our hats are off to all those volunteers who helped make this event today possible. The next mission maneuver is what?
For now, they got to do the spin maneuver this weekend, and then, like I said, it's from there they got to see, are they going to go back and sample, and if not, if they've got enough of a sample, their first priority is to get that sample back safely. So they're going to head back. I believe it's in December of this year. They're going to start the long trip back for 2023 to arrive back. When they arrive back, the whole spacecraft, of course, they're doing an Earth flyby. And Hayabusa 2 is doing the same thing. They eject the sample capsule and it's touching down over its proving ground in Utah. I believe that's where Stardust came in a while ago.
We don't talk about these things.
Yes, that didn't go so well. They got back a little bit. That didn't go so well.
They did do very good science.
Yes.
All right. So Pam, why are people scared of the sky, and should I worry?
No, I'm thinking there's nothing scary about the night sky coming up. And what I like to do is talk to people about things they can do. So what I'm going to tell you about tonight is that you can see planets in conjunctions. And I have kind of a list, dates, when, where to look for, that kind of thing. So I'll just go through it. In the evenings, like tomorrow night, you can see the moon coming really close to Jupiter and Saturn, and that's called conjunction. So the moon will actually, kind of move through and below the 2 planets for the next few days, including tonight. On the 27th, Neptune and the moon are in conjunction. Now, this is probably something that'll be much easier to see with a telescope. I think people can see it naked eye, but in urban locations, probably pretty hard to do. On the 29th, Mars and the almost full moon will be in conjunction. And, on the 31st, we're going to have a full moon for Halloween. I'm wondering again if we're going to have an orange moon. I saw one last time because we had upper level smoke here in Southern California. And all I could think was the great pumpkin rising above the horizon. It was kind of fun. In the mornings, the Orionids are very, prominent right now. This is like the peak time to look for them, but there is a range. And that started on the 2nd of October, goes through the 7th of November. Again, the peak was probably this morning. You want a really dark sight. The moon is set by now in the mornings. So even the next, day or two, probably a pretty good shot at seeing some of the Orionids. And these basically are called the Orionids because the dust from Halley's Comet will appear to radiate out from near the Orion. It's an asterism. It's part of the constellation of Orion, though. And the next thing we're going to be talking about is Mercury is switching to the morning. In fact, on November 10th, it is the greatest Western elongation. And oddly, when we talk about the greatest Western elongation, it appears in the east. And I was reading up on it, and it talks about how, angularly far away from the sun it is. So this is the greatest distance from the sun moving west of the sun. So that's going to be in the morning on the 10th. And I've got a little teaser for you. The end of the year, we have another eclipse. Thanks so much.
That all sounds absolutely
and if you haven't observed,
you're muted.
If you haven't observed Mars yet, this is still an amazing time I'm observing and imaging nearly every night, and Mars is like amazing right now.
Yeah, very, very good. Fairly early in the evening still, right?
Right as the sun's going down, just look east, and it's almost never that bright. I mean, I could see Mars when it went near the moon a few weeks ago during the daytime. After sunset, you could still see Mars, which is rare to see.
Opposition is a fabulous thing. So we've got to enjoy it when we can, and this is a particularly close opposition. So tonight is a night of small objects, but some of them are larger than others. So, Michael, you have evidence of a broadside collision of a dwarf galaxy?
Very evocative title, yes. So we know that our galaxy has gone through some mergers in the past, because if you look out at the plane of the galaxy, you got this nice disk, and you can see some streams of stars coming out from it. If you want to Google, SDSS, field of streams, you can see these beautiful images of stars extending out from the plane of the galaxy. And so what causes that is you have small satellite galaxies that pass through our own galaxy. And in that process, their stars get kind of ripped away from that satellite galaxy, and they leave out this trail. The new thing that they found seems to be similar, not streams, but shells. And so what's the difference between a stream and a shell? Well, streams are usually, something that can go through the plane of the galaxy. These shells seem to happen if it's going kind of through the center of the galaxy. And so what happens is this small galaxy will come through the center, and as it pushes through, it kind of splays out, and those stars will eventually return. They're not going to escape. So the tide of the galaxy, they start to come back, and at that point where they stop, where they kind of do that turnaround procedure, you get what looks like a shell. And so we see this with other large galaxies, like in galaxy clusters. You get these nice little shells and ripples. It's kind of a orientation effect that, if you're seeing it kind of edge on, so all those stars are moving, they stop, and then they start to come back. And so we now see that in our own galaxy. And this is, due to some overdensity of stars that we knew about. We decided to track down the locations and the velocities of these stars. And it seems that this was an interaction that happened about 3 billion years ago. And it's kind of the first radial merger that we've seen where it went kind of straight through the center of our galaxy like that. So our galaxy eating smaller galaxies and leaving behind little remnants.
Galaxies eating galaxies. It is a thing.
Galaxy universe.
So I just wanted to share a quick update on Betelgeuse, and then we have 2 more mission updates, so prepare for a fast round robin. This week we also had news that my favorite red supergiant, had its distance measured in another way. Normally the way we measure the distance to Betelgeuse is with parallax. This is where if you look at an object from one point, it appears to line up with one set of extremely different distant things. But if you switch to looking at it from another point, in this case switching from eye to eye, or if you're looking at Betelgeuse with a telescope, switching from where relative to the sun you are from one point in the year to another, that change in position of the observer will create an apparent change in position of the object that you're looking at. And this allows us to do trigonometry and figure out the distance to things. Except Betelgeuse is a big old blobby star. It's about 45 microarc seconds across. Its parallax is more like 5 milliarc seconds. And that's hard to measure. And there's fairly significant error bars. And a group of people treated it like the variable star that it is, and instead looked at what is its fundamental mode period, what is its first overtone. This is the equivalent of if you have a bottle and you blow in it, you get that initial note. If you blow in it differently, you get a higher pitched note. Well, they looked at those two notes that the star pulsates with, and they were able to calculate how big must it actually be. They used that physics and how big it appears on the sky to calculate the distance. And the measurement they got was within the error bars of the earlier Hipparcos measurement. But it was on the close end of those error bars. They essentially brought the star to 25% of its previously thought distance. They shrunk the star in the process, but it still is believed to have started out at more than 20 solar masses. It's still expected to go boom. We just have to wait 100,000 years, at least. It's still in the helium burning phase of its evolution. It's got a ways to go. But it's kind of cool to learn that giant stars sometimes still have Napoleon complexes. All right, so a couple more quick updates. David, you had news on us from Bepi Colombo.
Yeah, last Wednesday, Bepi Colombo, the joint JAXA, Japanese Aerospace Agency, European Space Agency Mercury mission did its first of two planned flybys by Venus. And this one was about 7,000 miles. The one next year in August is going to be a lot closer, like about in the range of 400 miles. And of course, the big question on Venus right now that everybody has is it going to search for phosphine? And of course, this mission wasn't designed for that. I mean, they had their instruments on more to just do test calibrations and give us a nifty little animation of Venus flying by as it went past. But they did have their Mertis, the spectrometer, on board. And in theory, they weren't really hopeful this time. I think what they're looking for is 20 parts per billion, I think it is. And that's like, for this distance, they said probably not on this pass. They said next year's pass might be a little more opportunistic and able to see that kind of, with Mertis to be able to possibly pick something out. Phosphine, of course, is what's been reported over the last few months in the recent detection on Venus for a possible source of either life or volcanic activity. That's got everybody excited. One of the more interesting science stories. I thought it was interesting on that detection that when they were looking at Venus, they were actually looking at a baseline for a sterile world. Like that, if you read into the American Astronomical Society report, that they were going to use Venus as a world where there's no organic phosphine or anything like that. So they weren't even looking for it per se. So, but Bepi Colombo isn't going to arrive at Mercury until it's going to do 6 more Mercury flybys. It's actually interesting. It's going to be the second spacecraft after NASA's Messenger to orbit Mercury. And it's interesting how difficult it is to get into the inner solar system, into the gravity well, how many Messenger had to do those many, many flybys past Mercury until it finally braked and entered an orbit around Mercury. So that's going to be an interesting mission to watch. But next year, it's going to be doing another flyby. It did a flyby of Earth in April of this year too, so that was kind of interesting. It has to do these multiple flybys just to get into the inner solar system, so that was kind of interesting.
And my last news note is I'd just like to say the InSight mission finally has their mole buried under dirt. I saw that. This is a instrument that was hoped to be several meters under the ground by now, but they have had issues with the soil on Mars not having the anticipated consistency, and the mole just sort of made sand at the surface and bounced its way out of the ground. So they literally took the shovel of the InSight mission and pressed down on the mole. And now they're scooping dirt on top of it so that they can press down on the dirt and hopefully help it as it digs.
And we've all done a lot of stories. The mole is digging. It's not digging. Now it's digging. Now it's not digging. So
It's the long game. It's
yeah.
the long game. So we're just about out of time, but let's see what questions that we can bring up. So it sounds like Bepi Colombo, can they even see amino acids?
I don't know if Myrtus, again, it's designed for Mercury, which isn't really, it wasn't a life searching mission or even an organic searching mission, but the spectrometer on there, from talking to the researchers last week, I'm not quite certain that, like they said, they could detect things like phosphine at a certain range, but they didn't sound very hopeful on this last pass.
So Michael, I think this question is for you. Do the stars in the dwarf galaxy get splayed out with their interactions with the Sag A star?
Like together, or I guess it's a similar.
Go ahead.
Go. It's a similar process that I guess they're still staying whole, but the distribution of the stars is getting splayed out. So, we talk about these interacting galaxies like Milky Way is going to collide with Andromeda. You're not really going to have any stars that actually will physically collide. They're just going to kind of get tossed about. So this galaxy, it's not quite getting spaghettified. It's just the stars are getting thrown out. They're getting tossed out, but they're still remaining whole. But I guess in a sense, the distribution is being spaghettified.
Okay. And let's see what else we have in here. So Arjan asks, how is the samples? How are the samples from OSIRIS-REx getting distributed across the scientific community?
I know I heard that the University of Arizona was getting, for their science team, was getting 25%.
Yeah.
Canadian Space Agency is getting 4% because they had some contribution. In the Japanese Space Agency is getting 0.5%. I remember those numbers, which that doesn't add up to 100%. So I don't know quite what, that was a question I didn't see addressed in the press conference. What they're doing. Again, it's not a big sample size. 60 grams is not big to begin with. So, yeah. But probably JAXA's getting it because they also, with Hayabusa 2, there was some talk about comparing it with the other samples they brought back from Itokawa, from Hayabusa 1 and Ryugu. Hayabusa 1 brought back it was in the micrograms. It was teeny. They didn't even think they had brought anything back at first until they really took a close look in the sample container and they found the smallest of small shards inside there. So they did bring back and incidentally, this is the biggest thing anyone's brought back since Apollo, back when they brought back hundreds of pounds of moon rocks in that era. So this is, even that tiny amount of sample is the biggest thing that's been brought back for a while.
The Soviets did bring back stuff too, though. They had their own little rover which blasted off.
Oh, that's true.
We just count that as part of the Apollo era because we're rude that way.
I don't know if those were during or after the last Apollo. Now you got me thinking. It was after 17. Yeah. Okay.
So I think that's all we have for today. Pam, where can people go to learn more about what you do?
Friday nights, we are going to be on Facebook Live starting 9 p.m. Pacific time. So that's 10, 11, 12 in North America. And we would love to talk to you. We'll just do some of the same kind of things, what you can do. And we'll pick a topic and tell you some of the ones I've spoken about tonight on Friday night, 9 p.m. Pacific time.
Michael.
So I'm on Twitter at Michael Roderick, and I'm also hosting Astronomy on Tap with 2 other co-hosts, grad students at Penn State. So this Monday, 7 p.m. Eastern Time, come learn about spooky supernovae and spooky storms on extrasolar planets. We have trivia and prizes, which we can mail across the country, and we'll also show you how to make an astro cocktail.
Excellent. Excellent. David.
I'm frequent contributor Universe Today. I have an article tomorrow. There's two binocular comets that are of note right now, M3 Atlas and 88P Howell, that are worth checking out. An article that's about ready to come out tomorrow. And also Sky and Telescope, I'm going to be doing an update on OSIRIS-REx. And of course I have first book, forward by Dr. Pamela Gay. It's also a really cool picture of a sun gun in there that she gave me. And second book just out a few months ago. And I was in March Sky and Telescope too, so that was kind of nifty. Not the usual. I get news and notes in there all the time because I do their space flight beat, but I got an actual. I had my gear almost confiscated going into Morocco, and I got a story out of it. I was like, well, how can you traveling with gear, and what are the requirements, and how do you deal with it when they're like, what is this strange Canon looking thing in your suitcase? So I got a whole article in there about traveling with astronomy gear and getting it through customs.
Awesome. And what you failed to mention is you will be part, and I need to send you the exact time yet,
That's
of
right.
the CosmoQuest Hangoutathon this weekend, when we're going to be streaming for 36 straight hours. If you're watching this show on Twitch, you're in the right place. Come back starting 8 a.m. Pacific on Saturday morning. All the rest of you, check out twitch.tv/CosmoQuestX. 36 hours of science, guests, silly games, giveaways, and we're going to be building a scale model of the entire solar system in Minecraft, or at least the 34 largest objects in the solar system in Minecraft. If you're interested in joining, drop us a note over on the CosmoQuest Discord. Find out more at cosmoquest.org. All right, I think that's all we've got. Any parting words, anyone?
Good night.
Okay.
Happy Halloween.
Join the Weekly Space Hangout crew if you haven't. They're the ones who produce this show. They're the reason we are here. Thank you so much, as always, to the Weekly Space Hangout crew, and especially to Nancy Graziano, who completely got me through this evening, helping with tech stuff in the background. Shout out to you. So, see you all, and be well, and have a fabulous morning, evening, or afternoon. Bye-bye, everyone.
Bye.
Bye.